For this lab, we were tasked with creating a model to represent an actual and conceptual oscillating spring. The first step of this lab was taking the provided video and putting it into Tracker to track the X and Y position data of a mass as it hung from a spring moving in an oscillating motion. From there, I took this X and Y position data, exported it into a CSV file that could be plugged into my GlowScript program. From my GlowScript program, I needed two important values that could be calculated from my exported tracker data. The first was the spring constant of the spring in the provided video. I calculated this using techniques shown in the EdgeX videos. This technique involved calculating the average period length and mass of the object. For this calculation, I used the average period length of the mass in the y direction, or in terms of the y-axis, by finding the time it took the spring to reach its fourth oscillating period and dividing that number by 4, as well as finding the provided mass of the object. Taking this period of oscillation and mass, I plugged these values into the formula shown to calculate my spring constant to be 6.943266.7. The next value I needed to calculate was the relaxed length of the spring. This was fairly simple since I knew the extended length of the spring as well as just calculated the spring constant earlier. Plugging these values into the equation seen gave me the value 0.13260137. After calculating the spring constant and relaxed spring length, I plugged these values into my GlowScript program to create my predicted motion model, as well as the starting position of the spring and the mass. You will now see my GlowScript code running. As seen from this GlowScript output, my predicted and observed motions are very similar to each other. The predicted versus observed position of the mass in terms of the y-axis was nearly identical at first, before the predicted max height per oscillation became greater than the observed as time went on. The predicted position of the mass in terms of the x-axis was slightly shifted to the right of the observed, but other than this translation was very similar to the observed motion. I blame this slight shift to the right on the fact that I calculated the period of oscillation using values in terms of the y-axis and not the x-axis. I found the y period of oscillation to be 2.28571429, while I found the x period of oscillation to be 2.54377788. I attribute these differences in oscillation periods to unforeseen forces on the system, as well as errors in accuracy of my points in tracker. The second part of my tracker code graphed the changes in energy of the system. For this model, we graphed the change in kinetic, gravitational, spring, and total energy. As you see from the graph, kinetic, gravitational, and spring energy all oscillate, but their sums, which represent total energy, remains constant at 0. Because our total energies remain constant at 0, we can say our model satisfies the energy principle, since all the changes to the kinetic energy of the mass are caused by changes in the gravitational and spring forces acting on the mass. Now, finally, here is my GlowScript code link. Thank you.